All right, 4-4 in Advanced Algebra 2, some applications of using some systems. So first few examples here, we've got some systems in just two variables. They say solve each of the following using a system of equations. We got to define our variables first, write our equations, solve the system, and then write the answer in a complete sentence. So let's just kind of see what's going on here. A small theater is having an event. The theater holds 295 people. And when they sell out, the revenue, meaning the money they made from all the ticket sales, is this much money. The theater has general admission tickets for $30 and VIP tickets for $90 each. How many of each type of seat are in a theater? So notice I just kind of read the entire problem for a general overview, and then I want to check out the question. How many of each type of seat are in the theater? This is going to help us define our variables. According to this, don't they just have two different types of seats? So we're going to accurately define the variables. Now it doesn't matter which one's x, which one's y, or if you want to use other variables besides x and y, it's no big deal, but accurately define them. Don't just let x equal general admission seats and y equal VIP seats. It's the number of. So we're going to be accurate this go around. So x is the number of general admission seats and y is the number of VIP seats. And you can always pause the video if I'm moving a little too fast for you. So now it's time to write our equations. So let's go back again and kind of read through for details. It says the theater holds 295 people. So that tells us about how many seats there are. So if it's going to hold 295 people, there's going to be 295 seats total. And we know there's only two types, so I need all of the general admission seats, which I know how many there are now. We've defined them to be x. So all of the general admission seats plus all of the VIP seats, those should add up to be a total of 295 seats, right? That's what defining the variables does. It's how many GA seats are there? Oh, I don't know, so call that x, etc. Then the next equation will have to deal with money, right? So we've got some money right here, some money right here, and some money right here. So $30 for every general admission seat, so $30 for every general admission seat, plus $90 for every VIP seat. That'll equal the total of $13,050. Notice you don't need to put the dollar signs in this situation. It's just using nothing but the numbers. Boom, there's our system. Now we could solve this however we want, but folks, I'm telling you, the idea is to use the matrix now that we learned last class period. The matrix is going to make things a lot simpler. So I'm not even going to make you write down that coefficient matrix or the augmented matrix. We're going to just kind of realize we're going to type it right in. So I don't even need the augmented matrix. So again, how we do that is on our graphing calculator, we go to second matrix, and we want to edit. So we scroll over the top to edit, and then this is a 2 by 3 matrix. So 2 by 3, and again it asks us, maybe we can change our dimensions. We just hit enter a couple times because it's on 2 by 3, and we enter all our coefficients in. It's 1, 1, then 295, enter, 30, 90, and then 13,050. Enter. Make sure you hit enter. And the beauty of a 2 by 3 matrix is you can see all of those to make sure you typed it in right. The move now is to quit out of this matrix, and now we got to go back to second matrix, and now we want to choose the option of math, which is the middle option, and scroll to option B, which is reduced row echelon 4. And now the calculator's sitting there going, hey, which matrix did you want me to do this on? So you got to go back and finally select, we had this in matrix A, and hit enter. Now I do want you to write this down. This is the solutions matrix. So 1, 0, put this cool little guy right here, and you had a 225 right there, and 0, 1, 75. So the solutions matrix you will write down, that's 70, not 70. Yeah, 70, sorry. My bad. So in that situation right there. Okay, so this is our What we've done so far, we defined our variables, we wrote our equations, we did the matrix do the work for us, we write this down. Now we just answered in a complete sentence. So the idea is to read this. This really just says 1x equals 225 and y equals 70. So I can answer that in a complete sentence. And that is, of course, I have a small little typo there because I thought the answer was 75, but it's 70. There's 225 general admission seats. Right, that's what this 225 is all about. That's 225 general admission seats. And there are 70 VIP seats. So answering our question in a complete sentence. So we defined the variables, we wrote our equations, we let the matrix do the work. Here's our solution right here. And now there are 225 general admission seats, no abbreviations there, and 70 VIP seats. Let's try another one. An investor has $20,000 to invest. If part of it is invested at 8% and the rest is at 12%, how much should be invested at each rate to yield an 11% on the total amount invested? So they're going to do some mixing, basically. We've got some mixture problems here. They're going to do part of it at 8 and part of it at 12. They want the final, total interest to give me an 11% yield payback on that. So let's go one step at a time. Let's define our variables. They say how much should be invested at each rate. How much should be invested at each rate. So basically we've got the two rates, the 8% and the 12%. That's what they're mixing together. I don't know how much at each, so let's define some variables. Let's let x equal the amount invested at 8%. And y be the amount invested at 12%. Again, no shortcuts. Don't say x equals 8% and y equals 12%. It's nice and accurately defined. X is the amount they invested at 8%, and y is the amount they invested at 12%. So there's a little bit of common sense for the first equation. It's like, okay, they've got $20,000 to invest, right? All of the amount that they invested at 8%, that's x. Right? So like x plus all the amount they invested at 12% was y, and that totals 20,000. That's such a simple equation. It's so easy that it's hard sometimes. Like there's no decimals involved with that. We didn't do any of the crazy stuff. It's like all the amount at 8% plus all the amount at 12% add up to $20,000 is what they totally invested. Now we'll throw our percents in there. So 8%, remember you got to change that to a decimal by moving the decimal 2 places to the left, of the amount you invested right there, plus 12% times y should equal 11%. And here's the super trick. 11% of the total amount invested, so we got to take 11% times 20,000. Right, that's the big oopsie. You got to take this percent, that what it's supposed to mix to be, times how much money you put in there in the first place. So we can just leave it like this. You could actually calculate that if you want to, but the calculator will do that when we put it in our matrix. And man, this is the beauty of the matrix. With all these crazy decimals, I just think it's nasty solving this by hand, by elimination. So let's go to our calculator and use the matrix again. Let's go to second matrix. And I want to edit a matrix. The size of it is 2 by 3 still, so I'm on choice A. And I just got to hit enter a couple times to get down in there. So I want 1, 1, 20,000, enter. And then 0.08, enter. 0.12, enter. And here you can literally let the calculator calculate this for you. Do 0.11 times 20,000. And when you hit enter, it will actually figure that up to be 2,200, right? So that's the way I like to roll with it. Just let the calculator calculate for me. And then, of course, to do the reducer echelon form, we got to quit out of it. Notice I still have that operation saved from my previous entry, so I can totally just go second entry right there. That entry button again is above the enter, so I hit second entry. And then hit enter again, and boom, it will do it for me. I don't have to go through all that punching of all that stuff in again. So again, I'll write that solutions matrix down. That's 1, 0, 5,000, and 0, 1, 15,000. 5,000. Again, you're graded on writing all of this stuff down because the calculator's doing all the work for us. I just want to see what you got. So here's the defined variables. Here's the two equations that you wrote. This is that. And now let's put this in a complete sentence. What does this mean right here? This is X, right? X is the amount invested at 8% equals 5,000. So in a complete sentence, I wrote they should invest $5,000, right? That's this bad boy right here, at 8%, and $15,000 at 12%. Again, you can pause the video to get yourself time to write that sentence down, but it's just totally take this and write it in a complete sentence. All right, let's keep on rolling on. A 25% salt solution is mixed with a 10% salt solution to produce 100 grams of a 16% salt solution. So they totally mixed these two together. Like these two got mixed, and this is the percent they got back. How many grams of each was used? So I need to define my variables. And again, the question helps me. They're asking me about how many grams of each. Well, each means the two guys that they mixed together. So I'm going to let X equal the grams of the 25% solution and Y equal the grams of the 10% solution. And I probably should spell solution right. So again, you can pause that video to accurately define those variables. And now let's write two equations. So again, it's so easy that it's hard. They're mixing 100 grams together. Well, how many grams of the 25% solution did they mix together? X. And how many grams of the 10%? Y. That should add up to be 100 grams. Right? X plus Y equals 100. The second equation is where you throw them percents in there. So change them to decimals. 0.25 times the grams in that, like 25% of it, plus it was 10% of Y, should equal the other percent, 16%, times the total grams amount that you had from the top. So it's always like boot times brat right there. And now to the matrix we shall go. Second matrix, scroll over to edit, and I'll let you punch those numbers in on the 2 by 3. So 100, 0.25, boom, 0.10, boom, and 0.16 times 100, which should give you back 16, which is a winner. Then you quit out of it. And again, my previous entry is reduce our echelon form on matrix A, which is exactly what I want. So I'll hit second entry, and it says, there it is. Boom. There's my solutions matrix. 1, 0, 40, and 0, 1, 60. Remember, these two numbers should add up to be 100, which they do. And we'll write our answer in a complete sentence. What the heck does this mean? It means they used 40 grams of the 25% solution and 60 grams of the 10% solution. So capital letter, periods, nice complete sentence right there. Okay, one more with two variables. 10 pounds of mixed nuts at a food co-op are to sell for this much per pound. The mixture is obtained from mixing two kinds of nuts. They mixed one variety at $4.29 per pound and the other one at $6.55 per pound. So these are the two that got mixed together. How much of each must be used? Let's define our variables. So X is the amount of the $4.29 brand or variety, and Y is the amount of the $6.55, because these are the guys that are getting mixed together. Simple enough. Writing our two equations. The first one is real tricky because they give you a little visual optical illusion. Like it visually looks like they only gave you like 3 numbers in here. Like these two, which we've used, and this, which is the mixture money, and it's hard to find that fourth number of like what they all should add up to be because they put it in words instead of in numbers. 10 pounds of these mixed nuts. So X plus y should equal 10, man. It's like all the pounds of the 429 and all the pounds of the 655 should add up to be 10 pounds. And then the other equation is straight up money. So since x is dealing with the 429 times x plus 655 times y, and that should add up to be the 595 per pound, and we had 10 pounds. So please pause the video, get this punched into your calculator, and let the matrix do the work for you. And it comes out real nasty. I should have done that for you, but it comes out real nasty. So here it is. You go 1, 110, 4.29, 6.55, 59.5, and then you quit out of it and do your reduced row echelon form on it, and you get the nasties, right? That's fine. You're looking for the row of ones going diagonally, which we had, so I rounded them off to the nearest hundredth right there, about 2.65 and about 7.35. So it kind of freaks you out a little bit that it doesn't come out so nice. Just that's cool. It's all good. And then that means that they should use about 2.65 pounds. So notice the key word that I put in there was about, because it was approximate, of the $4.29 variety, and about 7.35 pounds of the $6.55 variety. So don't freak out that that didn't come out so nice. Okay, those were all in 2 variables. Now let's do some in 3 variables. Same situation. Define variables, write your equations, use the matrix, and then write in a complete sentence. So let's dive in. A theater owner wants to divide an 1,800-seat theater into 3 sections with tickets that cost $20, $35, and $50, depending on the section you sit in. He wants twice as many $20 tickets as the sum of the other kinds of tickets, and he wants to earn $48,000 from a full house. All good. I've just read the whole problem. Now here's the question. How many seats should be in each section? So we're in 3 variables, and we just got to realize they're asking us about the types of seats. Well, we've got 3 different kind of seats. A $20 seat, a $35 seat, and a $50 seat. So I'm going to define my variables like so. I'll use x, y, and z. And I say that x is the number of $20 seats, y is the number of $35 seats, and z is the number of $50 seats. So let's write our equations now. There should be 3 different equations because we're going to need a 3 by 4 matrix to get this solved. So let's just kind of read from left to right, or from the start, and see what we got. 1,800 seat theater. Okay, well here's all my seats, right? I got $20 seats, $35 seats, and $50 seats, and these are the number of them. So the nice simple guy, all the $20 seats, plus all the $35 seats, and all the $50 seats, please cross your Z's, should be 1,800 seats. That's pretty simple. So let's kind of realize that I have used this. Newt, done with him. The other easy equation to deal with is the money part, right? So I'm kind of skipping around from easiest equations to right to hardest. You've got a $48,000 like full house is what you should get from a full house. So that's where you throw all the money with all the equations. So $20 for every one of these seats, and $35 for every one of these seats, and $50 for every one of these seats. My pen would cooperate. Should equal the total of $48,000. And now I'm done with him. The only thing I got left to write about is this part. He wants twice as many $20 tickets as the sum of the other kinds of tickets. This one takes a little bit of, let's go off to the side and figure some stuff out. So he wants twice as many $20 tickets as the sum of the other kind of tickets. So as the kind of shows you that there's like an equal sign right there. As the sum of the other kinds of tickets, well, if they're talking about the $20 tickets, remember we let that be x, so the other kind of tickets are y and z, so I definitely know I need the sum of those, and I need twice as many of these to equal the $20 tickets. So you got 2 options basically. let me kind of put you as this option in blue or this option here in green. And it's very hard for people to realize which one is correct. It's like you need twice as many $20 tickets as you do the sum of the others. So here's what I like to say. It's like, let's just make up some numbers. Let's say the sum of the other two tickets was 10, right? And then what would you have to do to it to get twice as many? Wouldn't you have to double this? You'd have to double the sum to make that equal what you want, because this guy should equal, if there's 10 of these, there should be 20 of those bad boys right here. And the way you get that is you take the 10 times the 2 right here, and that will give you 20 of these. So it's very, very, very tricky. The correct equation that you're looking for right here is this guy, that the number of $20 seats should be twice as many as the sum of those guys added together. Well, this equation, to put it over here, doesn't do us a lot of good, because we need the variables to go in the order of x, y, z equals number. Otherwise, the matrix can't help us. So I got to like distribute this out. So x would equal 2y plus 2z. And then you got to get the x over here, the y over here, and the z equal here. So you got to subtract all these over. So x minus 2y minus 2z equals, all of this stuff is gone, so nothing right there. So you've got x minus 2y minus 2z equals 0 in that situation. Now we are ready to let the matrix do the work. So we'll go to second matrix, and we want to edit, but now we're on a 3 by 4 matrix. So if you don't have that, just select a different matrix down there, and you could make it 3 by 4 right here by typing a 3 there and a 4 there. If you already had it, awesome. And I will let you type this in. It takes me so long to type this in. Just pause the video for a second to get all these coefficients typed in. So I typed mine in. The hard part about the 3 by 4 is you can't see the whole thing at one time. So, and also if you get some errors or anything, you probably use the subtract 2 instead of a negative 2. Make sure you're using the negative sign, not the subtraction symbol. So just, you can scroll left and right to see that you have the entire matrix typed in there correctly. Now I need to quit out of it. And the previous entry is set on reducer echelon form for matrix A. I don't want that. So I'm just going to go through the whole process again. I hit second matrix, go to math, choose reduced row echelon form, which is option B. And now I want to tell it which matrix to do that on. So go back to second matrix, and then you got to scroll down and select matrix B, and boom, there he is. There is our solutions matrix. So you can write him down and then answer the question in that situation. So there's my solutions matrix, nice and neat right there. And then to translate it, I kind of am answering in a complete sentence. They're talking about the theater owner. So the owner needs $1,220 seats, $435 seats, and $250 seats in that situation, because that's what this is. X equals, Y equals, Z equals in this situation. One more, baby. A trust manager has $500,000 to be invested in 3 different accounts. This is what the accounts pay in percentages, respectively, and the goal is to earn $49,000 with the amount invested at 8% to equal the sum of the other 2 investments. So don't let all that mumbo-jumbo confuse you. That's just reading it for a general overview. Go through it one step at a time. First, by defining the variables, you should read the question. How much should be invested in the 3 accounts? So let's define 3 different variables. You got X, Y, and Z, and these are the 3% that they listed them at. Again, pause the video so you can get that written down. Okay, so the question is, when you add X, Y, and Z together, what should they add up to equal? Should they add up to equal the 500,000, or should they add up to equal the 49,000? The 500,000 is the money that they totally have to invest. The 49,000 is like what the interest that they want to earn on this stuff is. So when it comes to what X, Y, and Z is, since this is the amount that they're going to invest, that should all add up to be 500,000. So X plus Y plus Z add up to be the 500,000. This is the total amount of money that this guy gets to invest in these three different accounts. The next part is all the interest. So 8% times X, because that's what we let X stand for, plus, 10% times Y plus 14% times the Z. That should add up to the total interest that they want, which is 49 grand. And then the third one is that's where that complicated stuff comes in. So if you like to highlight, it's cool. It says with the amount invested at 8%, bling, what a nice word there, equal to the sum of the other two investments. So the question is, how much was the amount invested at 8%? I wonder, how much was the amount invested at 8%? That is literally X. So the amount invested at 8%, I'm going off to the side because I can tell that this isn't going to be in the right order that I want it to be in already. It's not going to go X, Y, Z equals number. So I'm writing this equation off to the side. The amount invested at 8% is equal to the sum of the other two investments. So Y plus Z. They didn't do twice it or any of that crazy stuff right there. So pretty simple one right there. And now to get it in the right order, you've got to subtract the Y over, subtract the Z over, so you're left with X minus Y, because it got subtracted over, minus Z equals, when you move all that stuff over, you're left with 0 right there, baby. And now the rest is yours. Type that bad boy in a matrix and get the solutions matrix right here and write the answer in a complete sentence. If you please pause the video, and then when you come back, I'll have that shown for you. Here it is. Hopefully, if you didn't make any typing errors, this is what your solution matrix should look like. And that means the account manager should invest $250,000 at 8%, because that's what X equals, $150,000 at 10%, and $100,000 at 14%. Cool. That's it. Let us know if you have any questions, and have a good one.